Hello everyone, welcome back to LABrary. I am Miss Kathleen and this is part 2 of our program on secret science experiments. So last week we talked about doing 3 different experiments. The first one involved bread and lemon juice and making a secret message on the bread. The second experiment was one that involved using a crayon or I had a pastel crayon, but it had to be white, and writing a secret message on a paper towel. The reason we're in the kitchen is because those 2 experiments are things that can take place in the kitchen. And we were going to involve our family members in these experiments. That's why they were secret science experiments. So let's get right to the bread experiment, okay? Our piece of white bread, our little paintbrush. I've got lemon juice in here from a fresh lemon, and I am going to paint a smiley face with 2 big eyes. And on the other side, remember we wanted to do it on both sides, I'm going to paint a bullseye. So circle in the middle and then a big circle around the outside. Okay, we are ready to toast. Okay, so here's my toaster oven. I'm going to pop it in. My toaster oven is a little tricky when it comes to toasting, so you can get it like not too toasty, just right. Okay, we'll be back to see if our secret message does that. Okay, I think it's almost ready to be finished toasting. I'm going to plate out. It's going to be hot. I think there is something on it. I think we can see it. Finished toasting. Okay. Out it comes. Ouch. Okay, you guys, look. We have a happy face. Let's see how the other side turned out. It looks more like a happy face than a bullseye. Okay. But the happy face worked. So let's talk about what happened. What was the chemistry that was happening here? Okay, so what was happening with the lemon juice and the bread? Well, what was supposed to happen, and I actually made it fail. It worked in a different way, which is kind of interesting. But I wonder if it would have worked with water too. So maybe you can try an experiment to see if it would have worked with water. What I forgot to do was wait until the lemon juice had dried before I toasted it. I was hasty. So what it's supposed to do is oxidize when the lemon juice hits the heat, or the heat hits the lemon juice. So it should have turned a darker color than the rest of the bread. So that was a bit of a fail, but I mean, it still worked. But the reason that it worked is because these little bits are a little bit cooler. They were wet, so they didn't toast as well. All right, so what's the science behind oxidation? We talked about that the lemon juice should have oxidized on the bread. When the heat hit it, it should have turned brown. Not all substances that oxidize are going to need heat in order to oxidize. Sometimes they just need oxygen. So think of other fruit juices or fruits. So say slice an apple and leave it out, and when oxygen gets to it, it's going to turn brown. The same with pears or bananas. Other fruits you can think of are also going to oxidize. So if I hadn't made our experiment a fail, then the smiley face and the bullseye should have turned brown with the heat. Okay, our other experiment, well, our second experiment, was the secret message on the paper towel. And here is my white pastel crayon. You could do it with a regular crayon too. We're just going to deposit some of the pastel on here. I think I will make a heart. Okay, and then I'm going to spill something. You shouldn't be able to see it because it's white too much. And if somebody is just ripping a paper towel off, they're not going to see it. You might be able to see their heart there, but I don't know. Oops. Oh dear, I spilled some Diet Coke. Oops. So let's rip this off, like someone in your family will, to clean something up. Ha-ha! The heart shows up nicely. How did that get on there? What a mystery. Obviously, what was happening with the paper towel is no secret. We have a substance that is waxy, which is going to create a relief surface or, a relief surface on the paper towel. So when a darker liquid shows up on the towel, it's actually only going to be absorbing into the part where the waxy substance is not. And because we made it white, no one could see the message until they used it. So that's the secret part of it. Okay, so we are in the bathroom. It's my mirror. There's my bathroom. Okay, so we are going to, I put a couple of drops of this liquid detergent in here. This is my just plain water. I'm going to dip my cotton swab in there and then just tap it off because we don't want it to run, our secret message that we're going to write on the mirror. I want to make sure that I have enough of the soap though too. Okay. I'm just going to make a heart. I'm always making hearts. Let's see, where did I start it? Uh-oh. Very secret. Right there, maybe. Okay, I know you can't even see it. Well, it is super steamy in here. Okay, can you see the heart? It's right there. You can kind of see it. Sorry, it's hard with my camera. Anyway, the heart is there. The surfactants in the soap have made a little message appear. All right, what's the science behind our soapy water message on the mirror in the bathroom? Well, soap molecules reacting with the water molecules they break up the surface on the mirror. So the water does not create droplets wherever the soap is. And that is the hydrophilic part of the soap. So there are two reactions with water. Hydrophobic, meaning that that part of the soap rejects water, and the hydrophilic part attracts water. And that is what is happening with our soap experiment on the mirror. All right, thanks so much for joining me today for LABrary and following through with our secret science experiments, our mysterious messages from last week. I hope you had as much fun as I did. And next up is Mr. Travis with a new challenge for you this week. Next week, I will be back with a new challenge. All right, have a good one. Bye.
Hello, my fellow librarians. Mr. Travis here, and I've got another challenge for us this week on the LABrary. And this week we're going to talk about friction. And friction is basically talking about what happens when two things sort of touch each other and it affects their speed, it affects their momentum. So like things that have a lot of friction, basically they rub against each other and it really will slow the one thing moving down. Things with not a lot of friction, things will keep moving faster. So things that have a lot of frictions, so say if you're walking in your house and you have a thick rug and your sneakers and you're moving along, or if you try to slide on a rug with your sneakers, that rug is really going to grip on your sneakers and you're not going to be able to really slide. Now, on the flip side, if you were to go out onto your driveway on a cold morning and there's ice on it and you were to run and try and slide, you could slide, you know, the length of your driveway, or, you know, an ice rink. Ice has very little friction. It's smooth. In fact, one trick that if people are stuck in the ice and stuck in the snow where their tires are just turning because they can't get friction, throwing something under your tires with friction can get your car moving. One thing I know that people use is like kitty litter. You can dump kitty litter under your tires. It gives it enough friction that you can get your car moving again. So we're going to explore friction this week, and what basically we need something that will move. So if you've got like a toy car at home, I've got a little toy train with moving wheels, and I've got a little moving crab on wheels. And then what you'll want to do is get some cardboard, something like this. And first what you're going to do is kind of play with making your own ramp. So how fast things go on a ramp depend on what's called the slope, or the angle. So if I have this and it's pretty much straight and I put my train on it, it's not really going to move. But if I angle it a little bit like that and put the train on it, I won't even have to touch it, and it starts moving. Okay, and the more I turn it, of course, the faster it's gonna go. So, and here's my little crab. Ooh. So what you're gonna do is you're gonna build a ramp, and then I want you to experiment with friction. So you can build multiple ramps or the same ramp and put different items, make a track. So maybe a track here, here, and there, and put different sorts of things on the bottom, different kind of materials on the bottom. What can you do instead of trying to make your car go faster? You're actually trying to slow it down. And before you do it, make a prediction. What do you think is going to happen? What things will make things go slower and slower and slower? And then maybe you can even move the ramp more and see and time it. So you can sort of time how long it takes your car to get down the ramp or to a certain distance. Time it, see how long it takes to get down there on one material, then put another one and see, and you can time it. And then move this slope even higher so there's more slope and see how that affects it. So what you're going to do is you're going to play with different things that cause friction. The more friction, the slower it'll go. And then also test and time to see if your predictions about what things will make things go slower is correct. So, and again, there's all sorts of things that you can think about that you might have around the house. Basically, you're trying to slow down your car. And what are you going to use to do that? Obviously you want it to slow down. You don't want it to stop, so you can't build a wall. So what kind of things can you do to slow this thing down, but still get it all the way off your ramp? And then I'm gonna experiment and do some different kinds of things, and I'll show you what I do next week. So anyway, that's it. If you want to send in some of the stuff that you experimented with, just send it to my email. It's travis@mld.org, or just tag us on social media at Meridian LABrary. Love to see it. Anyway, we'll see you next week. Have fun with this.